Welcome to Math with Mrs. Cox. We're on Chapter 9, Lesson 13, Subtracting with Renaming, page 689. If you have not had a chance to watch the Math Antics video on regrouping with subtracting fractions, I highly suggest to do so. This is one of the toughest chapters in the whole book, but I know you guys can handle it, and I know you can do well. Just follow the instructions really well, and make sure before you subtract, the number on top is bigger than the number on bottom. All right, let's begin. All right, so we are setting up a subtraction problem. A black sea cucumber has an average length of 2 feet. That's what that thing is right there. A spotted sea cucumber has the average length of 1 1/3. How much longer? That gives us a clue that it is a subtraction. Is the black sea cucumber then the spotted? So we could estimate roughly that we're going to have 2 minus 1, which is going to be about 1. Then we can stack the number. First thing you need to do is stack the number. Right here, they have that you cannot take 1/3 from 0. There's nothing here for us to subtract from. So now they want us to add a number there. So we're going to change it into 1 3/3, which is the same as 2. It just means we have a fraction here that we can subtract from. Now we have a large number here, and we can take away that small number there. So 3 minus 1 is 2/3. We regrouped the numbers so that we could subtract. It still makes the same number. That still means 2. That still means 2. This just plays nicer together. Okay, do you follow with me? So then the average is 2/3 longer than the average spotted sea cucumber. They both look kind of creepy to me. Okay, now here is our problem again. We are going to subtract 4 2/8. And we're going to subtract from it 2 5/8. But notice 5 is bigger than 2. So we cannot take 5 from 2. So we need to regroup this number and bring it over. So we're going to take 1 from 4 and turn it into 3. Then we're going to add 8/8. Now this always confuses people when I do this. 8/8 is the same as saying 1 whole. So I took 1 whole number from here, turn that into a 3. And add it over here. So 2 plus 8 is going to be 10/8. So I can write it like this, 10/8. Now that's top heavy, and when you simplify it, it's going to come out to be 2 over here to this number to 4 2/8. But we need to have it top heavy so we can subtract 10 minus 5 to equal 5/8. Then we can just bring it on down. 3 minus 2 is 1. So our answer is going to be 1 5/8. Okay, follow with me. I don't want to lose you just yet. Again, we are subtracting. Every single problem in this chapter is going to be the same. This number is going to be little. This number is going to be big. So we have to borrow from this whole number. So we're going to borrow from that whole number, turn it into a 4. We need to add a whole number to 2/5, and it's just easier to add 5/5 because 5 is the denominator. 5/5 equals 1 whole. So 2 plus 5 is 7/5. Bring the 4 over. So that is our number. Yes, this is top heavy, and it's supposed to look like this. So that way we can have 7 minus 4 is 3. Bottom number's fifths. And then we have 4 minus 3 is going to equal 1. So our answer is 1 3/5. Okay, hang on. We'll still figure it out. I know a few of you are still kind of confused. Now remember, every problem is going to be this way. We're not going to be able to subtract it because this number, this numerator, is going to be bigger than this numerator. But they do have the same denominator, so that's a little bit nicer, right? Okay, so we have to regroup. We have to borrow from that and turn it into a 3. And I like to add 8/8 over here. 8, 9, 10, 11. That's going to be 11 eighths. And just so I can understand it, I'm going to bring that 5 eighths over. So in my mind, it's all nice, pretty, and organized. 11 minus 5 is going to be 6, and the denominator will be 8. 3 minus 1 is going to be 2. Okay, you get to try your own on number 3. Ooh, a couple of things you need to do here. First of all, now let's regroup first. First of all, you need to regroup and turn that into a 2. Then we're going to add 6, 6 over here. So this is going to be 2 and 7, 6, minus 1 and 1/3. But looking at that, they don't have the same denominator, now do they? But don't worry, you're pros at this. Go ahead and draw that line out, and you're going to get the same denominator, an equivalent fraction. Let's try 6. All right, 3 will go into 6 twice. 6 will go into 6 once. 7 times 1 is 7. Now I'm going to let you figure out the rest. Subtract that, give me your answer, and subtract these whole numbers over here and give me your answer. Okay, number 4. Alrighty, looks like we're going to need to just extend this out. I'm going to do 8. Go into 8 4 times. 4 will go into 8 twice. I forgot to add a number there. Oh, I can't subtract that though. That's right. I can do it this way as well. I'm going to borrow from here. Then I'm going to add. Get my arrow going right. There we go. That's a cuter arrow. I'm going to add 8 eighths. So 2 plus 8 is 10 eighths. Now I'm going to bring my 4 eighths over here. Now I can subtract that a little bit better because this number is bigger. 10 minus 4 is 6 eighths. And 4 minus 4 is 0, so that doesn't do anything for me. But 6 eighths I can simplify. I can divide them both by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. So my final answer out of that great big mess is 3/4. Okay, number 5. Try that one on your own. So I can already see that that numerator is bigger than that one. So you're going to need to borrow. Turn that into a 6. Add 2 2's to that. So then you have 6 and 3/2 minus 3 and 4/5. And you do need to find a common denominator. Now work your magic. Number 6, 4 minus 1 and 1/8. Well, there's nothing here for me to minus. So now I need to change that to a 3. That's a crazy 3. Let me try that again. And then I can do 8. Let me write 8 eighths. Now I can minus. So 8 minus 1 is going to be 7 eighths. 3 minus 1 is 2. So my answer is 2 and 7 eighths. Okay, number 7, it's your turn to try it. There isn't any fraction right here, so you need to invent the fraction by borrowing from here, turning that to 11, and regrouping to 6, 6. Okay, same denominator. You can work your magic. Go for it. Number 8. Oh, yay. I'm going to stack them, though. I'm going to stack this one right here. They have the same denominator, but, that is not going to work. So I'm going to have to borrow from this side and add 7 sevenths to this. And so my new equation, since I ran out of room, 7, 8, 9 is going to be 9 sevenths. 6 and 9 sevenths, subtract 6 and 4 sevenths. So 9 minus 4 is 5 sevenths. 6 minus 6 is 0. So my answer is going to be just a lonely 5 sevenths. Okay, so what you're going to do is you're going to want to stack them so you have plenty of room. I didn't have very much room on that last one, so don't repeat my mistake. And look at that. You're going to have to rename and borrow, turn that into an 8, and add 10 tens to that. So that's going to be 13 tens, 7 tens. Then you're going to have to subtract, tell me the answer, probably simplify, and then you're going to have to subtract these guys over here too. So give me a whole number and a fraction answer. Number 10. We're going to write the answer, write our numbers, our fraction right here. And I cannot subtract them. I have to rename. So I'm going to borrow and turn that into a 9 and add 3/3 to this side. So 1 plus 3 is 4/3. Bring the 2/3 over here so it looks all nice and pretty. 4 minus 2 is 2/3. And then I have 9 minus 3 is going to be 6. So 6 and 2/3 is my answer. Okay, number 11, go ahead and set it up. Ooh, you're going to have to rename. You're going to say 17 and then 4 fours, which is the same as saying 18, just now you have a fraction, minus 9 and 1/4. Okay, go ahead and finish the problem. All right, 13 minus 4 1/3. Well, I can tell I'm going to have to rename it and call it 12 and 3/3, which means the same as 13, minus 4 and 1/3. Haha, they have the same denominator. I'm in business. 3 minus 1 is 2/3. Then we have 12 minus 4 is 8. So that's my answer is 8 and 2/3. Okay, number 13 is all yours. You can stack it like this. Subtraction. Okay. Oh, looks like we need to rename it. So we're going to say 4 plus 4 fourths. So then we're going to have a new problem of 4 and 5/4. Subtract 1 and 1/2. Now you have to find a common denominator, which I think 4 would work really well. Okay, go ahead and finish all that out. Subtract your whole numbers and tell me your answer. Okay, we're on number 14. Is the difference in length between a monarch butterfly and a bumblebee greater or less than the difference between a walking stick and a grasshopper? Explain your reasoning. Whew. Okay, so a couple of crazy things. First of all, we're going to have to do a monarch butterfly and a bumblebee. Okay, find out the subtraction answer to that one. Well, let's do that first, shall we? Okay, so we're going to have a monarch butterfly, which is this length, and a bumblebee, which is this length. Okay, we need to subtract. Now, I cannot take 5 from 1, so then I have to rename and turn that into a 2. I'm going to add 2 2s to here. So then my new problem is going to be 2 and 3 seconds. Subtract 5/8. Ooh, I'm going to run out of room on this one. So I'm going to turn them both into 8. Ooh, that's pretty small writing. So 12 minus 5, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be 7/8. Now I have to subtract 2 from nothing. So 2 and 7/8. All right, so that's my first equation after the monarch butterfly and the bumblebee. Next, I need to find the difference between a walking stick and a grasshopper. So walking stick and a grasshopper. Walking stick is 4. Grasshopper is 1 3/4. Well, I can tell right away that I'm going to need to change that 4 to a regrouped number. So 3, and we'll say 4 fours, which still equals 4. Now I can subtract 4. I can minus 3 from it. So there's going to be 1/4 left over. 3 minus 1 is 2. Okay, so there's my second number. They want to know, is it greater than or less than? So we're going to say 2 7/8 is greater than 2 1/4. Find the difference in length between the walking stick and the bumblebee. So we need to do walking stick and bumblebee for this one. Walking stick is 4, bumblebee is 5/8. Now that one's a little tricky to do, so I'm going to rename the walking stick, and I'm going to say it is going to be 3 8/8. Then I can subtract the bumblebee, which is 5/8. So 8 minus 5 is going to be 3. The denominator is 8. Bring the 3 down. So the difference is 3 3/8 of an inch. Whew, kind of deep. That was crazy. Brain builders. Arlo had 5 gallons of paint. He used 2 1/8 gallons for one project and 1 3/4 for another. How much paint does he have left? Okay, so we need to add these two numbers, then we need to subtract it from 5. So 2 1/8 and 1 3/4. There's a couple different ways you can do this, but this is the way that's easiest for my brain. Make sure I get the sign right there. They are not common denominators, like fractions, so we need to turn it into like fractions. 4 will go into 8 twice. Okay, now we can add them. So 1 plus 6 is 7/8. And then 2 plus 1 is 3. Now we need to take the 5 gallons and subtract 3 7/8. But it looks like I need to rename that. So let's take the 5 and rename it as 4 8/8. That way we can subtract this a lot easier. 8 minus 7 is 1/8. 4 minus 3 is 1. Whoops, there we go. So we're going to have 1 1/8 of a gallon. Goodness gracious, that was crazy. Number 17, it takes Danny 9 1/4 minutes longer to walk to the park than run. It takes Danny 3 2/3 a minute less time to ride his bike to the park than run. It takes Danny 15 minutes to walk to the park. How much time does it take Danny to ride his bike to the park? Okay, so we can figure this out. So we have 15 minutes. Okay, it takes Danny 3 2/3 minutes less time to ride his bike. So we are going to need to take 15 and subtract 9 1/4. Of course, we need to rename 15, so it's a little bit nicer to play with, to 14 4/4. Okay, now we can subtract that a little bit easier. So 4 minus 1 is 3/4. 14 minus 9 is 5. Now we need to subtract the 3 2/3 minutes. So 3 2/3 minutes. Okay, they are not going to work out because they are not like fractions. So I'm going to turn them into like fractions. They can both go into 12. Okay, I'm subtracting. So 9 minus 8 is 1, 12, and then 5 minus 3 is 2. Whew, that was crazy. So it's going to take Danny 2 1/12 of a minute to walk or to ride his bike to the park. There we go. That was crazy. How are equivalent fractions used for subtraction? And then my example. For the example, I am just going to put an arrow right here showing how I renamed those fractions and made equivalent fractions. Crazy stuff. All right, nicely done, friends. Go ahead and